a square footing with the given data. So let's not waste the time and start the problem. So first we have to read out the problem very carefully. Design a square footing of uniform thickness for an axially loaded column of 450 mm by 450 mm size. The safe bearing capacity of soil is 190 kN per meter square. Load on column is 850 kN. Use M20 concrete and Fe 415 steel. So as per question, WC is given, that is 850 kN. Bearing capacity Q0 is also given, that is 190 kN per meter square. For M20 grade of concrete, FCK is 20 Newton per millimeter square, and Fe 415 steel, Fy is 415 Newton per millimeter square. Now the first step for the design is load calculation. WC is 850 kilonewton, which is given. Now self weight of footing, that is WF, may be considered as 10% of WC, that is 85 kilonewton. In the last video I have already discussed about the aspect and procedure of design. On that video I have discussed that WF may be taken as 10% of WC, that is load of column. So WC plus WF is equals to 850 plus 85, that is equals to 935 kilonewton. So from this we can easily find out the area of footing, capital A, that is equals to WC by WF by QU or Q0, that is equals to 935, and by bearing capacity, that is 190, that is equals to 4.92 meter square. So side of the square fitting is obviously root over of the area, that is 4.92, that is equals to 2.22 meter, say 2.25 meter, we can assume is as 2.25 meter. So the factored soil pressure due to column load only Pu is equals to 1.5 into 850 by the area 2.25 into 2.25, that is equals to 251.85 kilonewton per meter square. At the right side of the screen, as per given data, the size of column is drawn, and as per our calculation the footing is also drawn. So each side of column is 0.45 meter and each side of footing is 2.25 meter. So next step is depth of footing calculation. So to calculate that, we have to use three criterion: one-way shear criterion, two-way shear criterion, and bending moment criterion. Among these three, which value is more, we have to take that value in our consideration. So first criterion, it is depth of footing by one-way shear criterion. That means shear should be act in either this side or that side. Okay, but in case of square footing, all sides are same, so we have to calculate it for only one time. Okay, so critical section shall be at a distance d from the face of the column. So you can see here, from the face of the column at d distance, the critical section is shown. Shear force due to factored soil pressure at critical section is equals to 2.25 within bracket 2.25 minus 0.45 by 2 minus d, that is the area up to this is the area, into pu, that is 251.85, that is equals to 566.66 within bracket 0.9 minus d. So now we can assume 0.2% reinforcement steel has been used. So for 0.2% of steel and M20 concrete, tau C will be 0.32 Newton per millimeter square as per table number 19 of IS 456 2000. Okay, you can check the table from IS 456 table number 19. Okay, so now shear force resisted by the section is equals to tau C into x into d. So x means one side of footing, and as this is square footing, we can take any side because this is same value. But in case of rectangular column, we should design it for two times, for x axis shorter span and for y longer span. So in this case we don't have to consider that because we are here we are designing square footing. Okay, so tau c into x into d, that is equals to 0.32 into 10 to the power 6 by 10 cube into 2.25 into d. So that is equals to 720 d. Okay. Actually the value of tau c is 0.32 Newton per millimeter square. By this 0.32 into 10 to the power 6 by 10 cube, I have converted it from Newton per millimeter square to kilonewton per meter square for our calculation. It will help in our calculation. Okay, so that is equals to 720 d. So this is equation 2. Now we have to equate equation 1 and equation 2. Then we get 566.66 within bracket 0.9 minus d, that is equals to 720 d. So from this equation we can get the value of d, that is equals to 509.99 by 1286.66, that is equals to 0.396 meter, that means 396 mm. So as per one way shear criterion, small d, that means depth, is 0.396 meter. Now next step, depth of footing by 2A shear criterion. Okay, this is also called punching shear. Now considering critical section is at distance d by 2 from the face of column. So we generally we take this in previous video. I have already discussed how we can use this and design steps and aspects. So critical section is at d by 2 distance from each face. Okay. So perimeter of the critical section will be 4 into 0.45 plus d. 0.45 is the value of one side of column, that is equals to 1.8 plus 4d. Now shear force at critical section is equals to pu 251.85 into 2.25 into 2.25 minus 0.45 plus d whole square, bracket close, that is equals to 1274.99 minus 251.85 within bracket 0.2025 plus d square plus 0.9 d. This is equation 3. Now shear force resisted by the critical section, the maximum allowable shear stress is equals to 0.25 root over FCK, that is equals to 0.25 root over 20, that is equals to 1.118 Newton per millimeter square, or we can write 1118 kilonewton per meter square, 1118 kilonewton per meter square. Now shear force resisted, tau c, that is 0.25 root over FCK, the value is 1118 into 1.80 plus 4D into D, that is equals to 2000